All right, hello everybody. My name is Mike Reynolds. I'm here to present some work that I've been doing with some colleagues, Rob McCann, Blair Armstrong, and Derek Besner. So what we're going to talk about today are two, I'd say, ubiquitous assumptions in cognitive science. Ones that we've decided to colloquially call the similarity assumption and the frequency assumption. And actually, I would go even a step further. They're not just cognitive science. If you're an animal researcher studying conditioned fear responses in animal models, these things would also hold true. So I would say it's ubiquitous in psychology. So the similarity assumption for us is going to be the widespread assumption in cognitive science that the more similar a stimulus is to an existing memory, okay, the stronger that memory is going to become activated. Okay, it shouldn't be surprising, right? And the frequency assumption refers to, again, the widespread assumption in cognitive science and beyond, that the more frequently a stimulus is encountered, say that the more easily that memory representation is going to become activated, okay? Or the more strongly that memory representation will be activated by a stimulus. Okay? So, the word frequency effect, for instance. Okay. Now, what we're going to try and do is examine both of these assumptions using a special class of psycholinguistic stimulus called pseudo-homophones. Okay. Now, a pseudo-homophone, like train, T-R-A-N-E, okay, is a non-word, so a legal, orthographically and phonologically legal, pronounceable string of letters that sound like a real word. Train, T-R-A-I-N. And I'm probably going to forget to spell everything out. So you're going to be like, so you can see train is different than train is probably going to happen quite a bit today. So these type of stimuli are exciting or interesting because they have a representation in lexical memory. You know train, you know what it is, you know how it's spelled, you know what it refers to, how it operates. You have all of these memories associated with train. But because it's a non-word, we can vary both of these properties. So we can vary how similar our pseudo-homophone is going to be orthographically to its base word, right? So how T-R-A-N-E is visually similar to train, T-R-A-I-N. And we can also manipulate in an experiment how frequently occurring or how frequently you're likely to encounter the base word. Okay, so we can manipulate stimuli, or we can manipulate variables that correspond to these two core assumptions. Okay, so today we're going to examine pseudo-homophones, and we're going to examine them in the context of the lexical decision task, probably one of the most commonly used psycholinguistic tasks, right? And so in a lexical decision experiment, you're shown a string of letters, the center of a computer screen, and the participant is asked, does the string of letters form a correctly spelled word? Yes or no, button press response, off you go. Okay. Now, in the context of an experiment with pseudo-homophones, you're going to have probably three types of stimuli. You're going to have real words like brain, which in this case happens to be the base word. For the pseudo-homophone, brain, spelt incorrectly. Okay, and you often have non-word controls as well, like brate. Okay. For us, what we're going to do is we're just going to focus on the pseudo-homophones, which are a no response. Okay, so remember, you're saying it's not a word. So for those of you that are familiar with frequency effects, you're going to notice things are going to go in kind of like we're predicting opposite directions, and it's because this would be a no response instead of yes response. Okay, so what predictions do these assumptions make for pseudo-homophones in the context of lexical decision? Well, you can imagine that the more orthographically similar a pseudo-homophone is to its base word, the pointer. Okay, anyway, so you can imagine how orthographically similar the pseudo-homophone is to the base word. The more strongly the memory for that base word is going to become activated, which means the stronger of a distractor it's going to become, right? You're going to want to say yes, right? Even though the right answer is no. And as a consequence, the time to respond to the pseudo-homophone should be longer. So it should take longer to make a no response to a pseudo-homophone, the more similar visually it is to the base word, because the stronger the base word is going to become activated. All right, so this should not be controversial to anybody. Again, So what about the frequency assumption? What predictions does the frequency assumption make for pseudo-homophones? Okay, so again, the higher the frequency of the base word, right? The higher the frequency of the base word, okay, the more activated the base word should become, right? The faster its activation should rise, et cetera, et cetera. And the more activated the base word becomes, again, the harder it should be to respond no. So it's the slower no responses should be. Okay, it's going to be a more powerful foil, let's say. Okay, well, what about the joint predictions, the joint effects of these assumptions? Okay, well, the more orthographically similar the pseudo-homophone is to its base word, so these high similarity pseudo-homophones, right? Here we have, like, for instance, dream to dream. Remember, I warned you that this might get confusing if you're not looking. And cough to cough, where you'll notice dream is very similar. D-R-E-E-M differs by only one letter, whereas cough differs in every possible letter position. It's very orthographically dissimilar from its base word. You would expect that the more similar it is to the base word, the stronger the base word will become activated. In fact, in the limit, you might even say that cough may not even activate its base word because it's so orthographically dissimilar. And therefore, you'd predict that the stronger the impact of base word frequency should be. So pseudo-homophones that are orthographically similar to their base word should be more likely to activate the base word, and therefore should produce a larger effect of its base word's frequency. Okay? At this point, many of you should be saying, well, why? Obviously, I mean, why are you even talking about this? We understand this. Okay, so we're going to examine this assumption, and obviously, I mean, there's a reason why I'm talking to you today. Right? So what we're going to do is we're going to examine the joint effects of orthographic similarity and base word frequency in pseudo-homophones. Okay, and thanks to COVID, we're going to examine these things in previously published data that was convenient, easy for us to access. Okay. So, but first we kind of need to come up with a definition of orthographic similarity. There's a plethora of these definitions. There's a lot of different ways you could do it, and we've examined, I swear, all of them. This is the one that we've ultimately decided to go with. So as you can see here, we have the low orthographic similarity pair. Here we have a high orthographic similarity pair. And all we did is we counted the number of shared letters, okay? And then we just divided by the number of letters in the base word. So here there's 0 shared letters, divided by 5 gives us 0, okay? And down below, you'll notice that we have 4 shared letters, again, over 5. And so we have an orthographic similarity or orthographic overlap of 0.8. Okay. For base word frequency, I mean, there's so many different frequency databases out there. We decided to use the HAL frequencies from the English Lexicon project. I mean, it doesn't matter. You get the same pattern no matter what you use. Okay, and again, we're going to be examining no responses to pseudo-homophones. And we're going to examine the main effect of orthographic similarity, the main effect of base word frequency, and the interaction. So all of these are going to be entered into the model. But today, for the sake of expediency, I'm just going to discuss the interaction. And for the graphs, even though we're going to analyze all of these as continuous variables, I'm going to, for illustrative purposes, dichotomize orthographic similarity so it's easy to see. Okay. The first study we looked at was by McCann, Besner, and Davilar, 1988. We had 80 pseudo-homophones, wide range of base word frequency, and a wide range of orthographic overlap. So you remember that the joint effects of these two variables predict a larger base word frequency effect for high orthographic similarity than for low orthographic similarity pseudo-homophones. And that's not what we got. In fact, we got the exact opposite, okay? So our high overlap or high similarity pseudo-homophones, these are ones in some cases differ by just a single letter, do not produce any base word frequency effect at all. Our low orthographic similarity pseudo-homophones produce a base word frequency effect, and it goes in the opposite direction. All right, okay, maybe, this data was collected a long time ago. Maybe there's something wrong with it. It's, not a lot of pseudo-homophones, who knows, right? Maybe the language system is qualitatively changed. I mean, okay. So we then looked at a second data set by Armstrong and Plaut. Again, they used lexical decision. We've got a lot more pseudo-homophones here, 363. And what's nice about this one is the pseudo-homophones were not not the focus of the study. So they were included as foils. They were never really analyzed. So it's kind of nice to go in and take a look. Okay. They also included a between subjects manipulation here. So they manipulated stimulus contrast. So they had high and low contrast presented stimuli, and it was manipulated between subjects. So we can kind of analyze the data twice, once for the high contrast condition, which included one group of subjects, and again for the low contrast condition, which included a different group of subjects. Okay, again, these are the predictions, right? A larger base word frequency effect for the high similarity items, minimal base word frequency effect for the low similarity items. And that's not what we get. So again, there's no evidence at all of a base word frequency effect for the high similarity items. These are the ones that should be activating that lexical representation the most powerfully and should be therefore be affected most powerfully by the properties of that representation. And we find no evidence of that. In fact, we find the opposite. Again, base word frequency effect is larger for the low similarity items, and it's going in the opposite direction. Okay. Again, you can be for the low contrast items, we get the exact same pattern. No evidence of a frequency effect at all for the low or high similarity items. We get a large base word frequency effect for the low similarity items, and again, it's going in the wrong direction. Okay, conclusions. Yes, I have time. All right, so two assumptions in cognitive science, right? The similarity assumption, the more similar a stimulus is to its memory representation, the more strongly it should be activated. And the frequency assumption, the more frequently you've encountered something, the easier it should be to activate, the faster activation should rise, okay, the more powerfully it should be activated. Okay? And our data are inconsistent with both of these assumptions. Okay? So inconsistent with the similarity assumption, as orthographic similarity increased, the effect of base word frequency decreased. This is the opposite of what we would expect. Pause for effect. Yes, nice. Inconsistent with our frequency assumption, which again, the more frequently occurring the item is, the more powerfully it should be activated by the stimulus, the harder it should be to reject. We found the opposite, right? We found that as base word frequency increased, the time to make a no response decreased. Right? So these patterns are the opposite of what this pattern, this joint and this interaction is the opposite of what every model of reading predicts. Okay, and now we've got a powerful take-home message for you guys, and I'm gonna have to read it because it is long. Okay. It is virtually virtually axiomatic in the realm of cognitive science that the more similar, the more similar an item is to its stored representation, and the more frequently a stimulus is encountered, the more strongly the representation will be activated. Our findings that this base word frequency effect decreased as the similarity between the pseudo-homophone and the base word increased, and that the base word frequency effect facilitated no responses are direct violations of these axioms. The lexical influences that we have found on pseudo-homophone processing indicate a need for a more adaptive and flexible concept of how similarity and frequency effects arise. And that's it.